Welcome back. Today we're going to be solving the Leetcode medium minimum stack. So the goal of this problem is we need to design a stack class that supports the normal push pop and top functions, but we also need a get min function which returns the minimum element in the stack itself. And every operation here has to be constant time, big O of 1. That's the catch here. So the main trick is we can't scan the stack to find the minimum every time. So if we have one stack, to find the minimum, we would have to scan through the stack. That would be big O of n. So we need a smarter structure so we can achieve that constant time required. So here is the idea. So instead of having just, I'm going to draw it out here for you guys. So instead of just having one stack here, we keep two stacks. So one normal stack, just called stack. And then we keep a second stack called, let's just call it min stack. A big S, that's fine. But min stack, so the original stack will store the real values, and the min stack will store the minimum value so far at every level. So the key rule is the top of the minimum stack is always the minimum of the entire stack. So let's just walk through with a quick example. So let's use the example one here. You can see the code right here. So you can see min stack dot push 1. So let's just push 1 onto the stack here. 1. And then the minimum so far in the stack is only one number, so it'll only be 1. There's only one number in the stack that's 1, so that'll be the minimum of the stack so far. And then now we push 2 here. Now we push 2 onto the stack, right? Stack is now 1, 2. And now the minimum is still 1 because the minimum of 2 and 1 is 1. So you just push 1 again simply. And then now for the third one, push 0. So then you push 0 on the stack. So 1, 2, 0. And now the minimum becomes 0. So now if I call the get min right here, get minimum, the get minimum function, I just return the top of the minimum stack here, which is 0. And that is constant time as well. Just looking at the top of the stack takes constant time. So now if I pop, though, remember when you pop, you have to pop from both stacks. So you can see we call pop here. So if you pop from both stacks, you have to pop from both stacks. So after popping, you pop 0. You pop 0 from the stack. So now the stack becomes 2, 1. And this stack just becomes 1, 1. So now the minimum automatically goes back to 1 because the top of the minimum stack is 1 again. So the summary of the whole trick is every time we push, we also push the updated medium. We keep updating the minimum, not medium, sorry. So every time we push, we also push the updated minimum. Every time we pop from both stacks. So this guarantees all operations are in constant time. So now let's transfer this idea into code here. So as you can see here, we have our class here. So first I'll create the class and initialize the two lists, which will be our stacks. So in the constructor self dot our stack, normal stack, which will hold our real values. And then we want another stack, call it min stack, minimum stack, that holds the minimum value at each depth. So now we got that. And now we need to go to the push function. So stack. So now line 1, we can just start with just pushing onto the stack. So stack dot append. We're just gonna append to the normal stack first. Append the value we're pushing. And then line 2 here is the key. So look at the value here. So if we have to get the minimum here, minimum of val, and then if min stack already has something, so the minimum of that and the top of min stack here, if self dot stack else. So the key here of this line is if min stack already has something. Let me switch this to -1 because we're looking at the top. So if min stack already has something, then the top element, min stack at -1, is the previous minimum. The new minimum is the minimum of the current value and the previous minimum. And if min stack is empty, then the value is the minimum by default, like we said before. So then we append that minimum into the min stack below. So we just do self min stack and the value here. So now after every push, both stacks stay the same length. They stay the same length, and minimum stack always knows the minimum. Now on to the pop, and remember we pop from both stacks so they stay aligned. That way the minimum rolls back correctly when we remove an element from the stack. So let's just simply pop self.stack.pop from both. This is the original stack. Just do min here. And now for the top, just return the last element of the main stack here. We'll return stack at -1. That will return the last element or the top element in the stack. And now for get minimum. So we have to return the minimum of the stack. So simply you would just return the last element of min stack because it stores the minimum at the current depth. So self stack at -1, which is a top element. So now if we run this, this should work. The test case is passed. Let's submit. And there you go.